Hey there, guys. So I'm going to talk about the four main parent functions today. Now, the four big parent functions are y equals x squared, which is the quadratic function, which we have right here. We have y equals the absolute value of x, which is we have right here, which is the absolute value function. We have the y equals x to the power of 3, which is the cubic function. And we have y equals the square root of x, which is the um, square root function. All of these functions have the vertex form of their function. Now, it's not called vertex form for all of them, but it's the point where their slope either equals 0 or like where the line begins on the square root function. Now, the quadratic function, you can use this form to find the vertex by using k, which will be the y value of the vertex, and h will be the other will be the x value of the vertex. Now h, you need to reverse it. So if it were if it were 1 in the box, it would actually, if it be -1 because of the subtraction sign, if it was -1, it would actually be 1. So if I were to show you here, if h was 1, vertex will be at 1. And if k were 1, its vertex would also be at 1. And it works this way for all of them. If I turn them on, you'll see they all start there, or their vertex is there, or something like that. The stretches and compressions. Now, there's vertical stretches and compressions, and there's horizontal ones. So we'll start with vertical ones. Vertical ones are outside, vertical stretches and compressions are outside the parentheses. Now, if I'll use the absolute value function this time. The absolute value function, if you can tell, when I make a 2, it stretches vertically. So you can tell that it stretches vertically because one of the x values will have stayed the same, but the corresponding y value will have doubled. So you can tell here at 2, 2, right here, that when I make a 2, it becomes 2, 4. If I were to make it 3, it would become 2, 8, or 6, because it is multiplied by whatever a is. Now, if I were to reverse that and make it a decimal point, I would compress it. So now that point 2, 2, if I were to make it 1/2, it would now become 2, 1. So it's just multiplied by whatever the a value is, and that is what you can tell. Now, those are vertical stretches and compressions. Horizontal stretches and compressions, we'll start with the horizontal stretch. It will be the reverse, 0.5. So if the point is 2, 2, if I were to take the b value for horizontal stretches and compressions, and I were to make it half, which would be a stretch, instead of 4, instead of 2 becoming 2, 4, and not 2, 2, it would actually become 4, 2. So the x value is being doubled here. Now if I were to make it 2, the b value 2, instead of it being 2, 2, or 4, 2, as it was when I doubled it, it will now become 1, 2. And that is a horizontal compression. And it looks similar to a stretch, but it's a compression. Because it is inside the parentheses. Now, I can also make these functions reflect across the axis. So, if I were to reflect b and make this -1, you can't really tell much of a difference, but it did flip. So the point 2, 2 is now -2, 2, and vice versa. So the point -2, 2 is now at 2, 2. But it's hard to tell with a function like this. it's easier to tell reflections with a square root function. Now or a cubic function, as you can tell, if I were to just make this one, they both would flip, and it's very easy to tell. So we'll use the square root function. If I were to make this negative, it reflects across the y-axis because you are making the horizontal values negative now. And if I were to make the a value, which is the vertical variable, negative, it would flip across the x-axis because you are making the x values or the y values negative. So that is what a reflection is. And if you were to make both of them negative, you would get a combination of the two, which would flip diagonally across both axes. Now, moving on to notations, there is a notation which is called function notation. Now, what that means is I would have an AF. So I'll delete all of these boxes, and I will show you that it is y equals the f of x. Now, without a slider, there is no possible equation. F of x equals anything. F of x can be any graph in the world. Now if I were to write y equals 3f of x minus 2 plus 3, it is not any of the functions we talked about, although it does look very similar to y equals 3x minus 2 plus 3 squared. So now this is a quadratic. And you can tell here that all these numbers here do where the variables were. Now this 3 right here, this 3 is the y value. And this 2 is the x value of the vertex. And this 3, if I were to make this no number at all, where it is 5, 3, 4, if I place a 3 right there, that 0.3 becomes 6. So you can tell it has been multiplied by 3, and it has been vertically stretched. But you can't, and you can tell that this is quadratic because of this 2 right here in the exponent. This, you can never tell what graph it is until there is some defining feature about it. So this could be, this graph right here, this function could be a quadratic or a cubic or a square root or any sort of function, any sort of graph in the world. All you know is that one of its points has been moved positive 3 units from where it was, negative 2 or positive 2 units, so it will be moved up to this point right here, and whatever the function is, it will be compressed by it will be stretched by 3 vertically. So wherever that function is, that is what will happen to it, and you know that for sure. You just don't know what function it is. Now, using a real life example, I took a picture of a lamp and I stretched the photo, and I was able to use sliders to help me figure out what the parabola would look like. So I knew that it would land around 5 for the vertex and about 9 because that's where it is, and so it took me just a little bit of guessing to get to 9.2. Now for the compression, this would be a vertical compression, making it wider than it would normally be. I had to guess a little bit on that because I wasn't able to tell exactly where it would go. But this is an example of real life use of these translations and functions and things like that. And you can really find just about anything in the world that will have a parabola or maybe a absolute value function shape or something like that. Thank you for watching. Thank you.